Most people trying to eat well after 50 are doing everything right, and a quiet, measurable process of gut deterioration is happening anyway. Not because they're lazy or uninformed or making obvious mistakes, but because some of the most widely trusted foods in the American health market contain ingredients that the aging gut handles fundamentally differently than the label implies. The fiber count is real. The health claim is legal. The biological effect is something else entirely. Gut health has become one of the most discussed topics in nutrition, and simultaneously, one of the most successfully obscured. The conversation rarely gets past probiotics, bloating remedies, and vague advice about eating more fiber. What it almost never reaches is the specific documented distinction between fiber that rebuilds a microbiome and fiber that quietly destabilizes one. That distinction exists. Researchers have been writing about it for years, and it applies directly to foods that millions of Americans over 50 are eating every single day with the genuine belief that they are doing their bodies good. The consequences of getting this wrong don't announce themselves loudly. They accumulate in digestive discomfort that gets attributed to age, in cognitive fog that gets accepted as inevitable, in inflammatory patterns that show up years later in blood panels and doctors' visits. The gut, it turns out, is connected to far more than digestion. And what disrupts it disrupts more than most people have been told. So the questions worth sitting with as this video unfolds are these. Which specific ingredients are doing the damage, and where exactly are they hiding? What does the science actually say about recovering a microbiome that has been running on the wrong inputs for years? And what does a genuinely gut-supportive diet look like for someone over 50? Not in theory, but in the grocery aisle, label in hand, making a real decision. The answers are more specific than you've been given before, and more actionable than you might expect. There's a version of aging that nobody warns you about. Not the kind you see in the mirror, the wrinkles, the slower mornings, the joints that need a little more convincing before they cooperate. This version is invisible, and it's happening in a place most people never think about until something goes wrong. The roughly 30 feet of living tissue that runs from your stomach to your colon, housing somewhere between 38 and 100 trillion microorganisms that have, for decades, been quietly managing your health in ways science is only now beginning to fully understand. The microbiome, that vast internal ecosystem of bacteria, fungi, viruses, and other microorganisms, doesn't stay static as you age. Research published in the journal Gut has tracked how microbial diversity, meaning the number and variety of different species living in the gut, tends to decline significantly after the age of 50. And diversity, it turns out, is not just a nice feature of a healthy gut. It is the gut's primary defense mechanism. When diversity drops, the ecosystem becomes fragile. Certain strains that promote inflammation begin to dominate. Others, the ones responsible for producing short-chain fatty acids, regulating the immune system, and protecting the intestinal lining, start to disappear. What's left is a gut that functions, but not well. A gut that's running on reserve power. What triggers this decline? The answer is complex, but several factors consistently emerge in the literature. Reduced physical activity, changes in medication use, particularly antibiotics and proton pump inhibitors, which are extraordinarily common in people over 50, shifts in hormonal balance, and, perhaps most significantly, changes in diet. Not necessarily eating less or eating worse in the obvious sense, but eating differently than the gut expects. Because the gut's microbial community was shaped over millions of years of evolution to process certain kinds of food, specifically the fibrous, unprocessed plant matter that human beings ate for the vast majority of their existence. When that template changes, the microbiome feels it first. Here's what makes this relevant to you right now in a practical and urgent way. The National Institute on Aging has documented a growing body of evidence linking gut microbiome decline to systemic inflammation. a low-grade, chronic, persistent immune activation that researchers now associate with cardiovascular disease, type 2 diabetes, cognitive decline, and accelerated biological aging. This isn't fringe science. It's increasingly central to how researchers think about why some people at 70 feel like they're 55, while others at 60 feel like they've been running on empty for years. The gut is not a supporting actor in the story of your health. In many ways, it's been the director all along. And yet, most conversations about gut health stop at a remarkably shallow level. More fiber, more probiotics, more yogurt with live cultures. The advice is well-intentioned, but it misses something critical, because not all fiber is the same. Not all fiber does what the label promises, and some of what the food industry has been calling fiber for the past 2 decades bears so little resemblance to what your gut actually needs that calling it by the same name might be the most consequential mislabeling in modern nutrition. That distinction between fiber that feeds your microbiome and fiber that confuses it is exactly where this conversation is going next. Pick up almost any packaged food marketed as healthy in an American grocery store and turn it over. Somewhere on that label, in numbers that are meant to reassure you, you'll find a fiber count: 5 grams, 8 grams, sometimes 12. And if you've been paying attention to nutrition advice for the past 30 years, eat more fiber. Fiber is good for your heart. Fiber keeps you full. Fiber feeds your gut. Your brain registers those numbers as a signal of quality, as evidence that someone, somewhere, made a responsible product. What the label doesn't tell you, and what the food industry has no regulatory obligation to explain, is where that fiber came from, what form it's in, and whether the microorganisms living in your gut will recognize it as food at all. The distinction that researchers in nutritional science have been pressing for years, and that has still not made its way into mainstream dietary guidance in any meaningful way, is the difference between intact fiber and isolated fiber. Intact fiber is exactly what the name suggests: fiber that exists within the original cellular structure of a plant. When you eat a bowl of lentils, a handful of walnuts, or a roasted sweet potato, the fiber doesn't arrive alone. It arrives embedded in a matrix of water, starch, protein, fat, polyphenols, and micronutrients, all physically bound together in a structure that slows digestion, feeds a broad range of microbial species, and behaves in the gut the way fiber has behaved for the entire history of human digestion. The American Journal of Clinical Nutrition has published extensive research on what scientists call the food matrix effect, the idea that the physical structure surrounding a nutrient fundamentally changes how the body processes it. Destroy the matrix, and you change the nutrient, sometimes beyond recognition. Isolated fiber, by contrast, is what happens when a manufacturer extracts a specific fiber compound from its original source and adds it to a product that wouldn't otherwise contain it. The extraction process strips away everything that surrounded that fiber in its natural state: the water content, the companion nutrients, the structural complexity that made it useful to begin with. What remains is a concentrated powder or syrup that can be measured, labeled, and added to cookies, protein bars, and breakfast cereals to make the numbers on the back panel look impressive. The gut receives it, but the gut doesn't quite know what to do with it. Not in the same way, not with the same results. This is not a theoretical concern. A landmark study published in Cell Host and Microbe, one of the most rigorous examinations of dietary fiber and the microbiome conducted in recent years, found that the type of fiber matters as much as the amount, and that rapidly fermentable isolated fibers can actually cause dysbiosis in individuals whose gut microbiome is already compromised or low in diversity. In other words, the very people most likely to be reaching for high-fiber packaged foods because they've been told their gut health needs attention, people over 50, people with digestive complaints, people managing chronic conditions, may be among those most likely to respond poorly to the isolated fibers those products contain. The biology here is not complicated once you understand it, but it runs directly counter to what the label implies. What makes this particularly difficult to navigate is that the FDA's current definition of dietary fiber, updated in 2020, does include certain isolated and synthetic fibers that meet specific physiological criteria, but that definition is still contested among researchers, and it does not require manufacturers to distinguish between fiber types on the nutrition facts panel. So when you see 8 grams of fiber on a label, you are seeing a number, not a story. You're seeing a quantity without context, a measurement without meaning. And the gap between that number and what your microbiome actually receives is where a great deal of modern gut dysfunction quietly lives. The names hiding in that gap, inulin, chicory root extract, soluble corn fiber, pea fiber isolate, are worth knowing, because some of them are on labels you trust. There's a particular kind of trust that builds slowly over years between a person and the foods they've come to rely on. A morning routine anchored by the same high-fiber cereal. A protein bar kept in the car for the afternoons when lunch didn't hold. A yogurt with added cultures, chosen deliberately because someone who cares about their health reads labels and makes choices. That trust is not naive. It's the result of paying attention in a food environment that is genuinely, relentlessly confusing. Which is exactly why what follows deserves more than a passing glance. The foods most likely to contain problematic isolated fibers are not the obvious ones. Not the chips, the soda, the fast food nobody is pretending is healthy. They are the products that earned a place in health-conscious shopping carts precisely because they signal responsibility. Protein bars are among the most significant offenders. The majority of top-selling bars in the U.S. use chicory root extract, inulin, or soluble corn fiber as their primary fiber source, not because these ingredients are nutritionally superior, but because they are inexpensive, add minimal calories, and dramatically improve the fiber number on the label. The bar feels substantial. The label looks responsible. The gut, however, is receiving something it did not evolve to process in concentrated, isolated form. Whole grain bread presents a more nuanced problem, and one worth particular attention because the marketing around it has been especially effective. The words whole grain do carry real meaning. They confirm that bran, germ, and endosperm are present, but they say nothing about how thoroughly those components were processed before the bread was made. Most commercial whole grain breads use flour milled to a fine powder, collapsing the physical structure that makes fiber useful in the first place. Research from the American Journal of Clinical Nutrition has shown that finely milled whole grain bread produces a glycemic response nearly identical to white bread. The fiber is technically there. The matrix that gives it meaning is not. Functional yogurts, the ones with added fiber, added protein, and a probiotic strain count printed on the front, represent a third category worth examining. The probiotic strains are real, but their survival through the digestive tract varies considerably, and the prebiotic fibers added to feed them are almost universally isolated. Inulin is the most common. For people with a healthy, diverse microbiome, modest amounts may be tolerated reasonably well. But for people whose gut flora is already disrupted, and after 50, that describes a substantial portion of the population, concentrated inulin can trigger bloating, cramping, and a measurable shift in microbial balance that moves away from diversity rather than toward it. A product designed to support gut health, consumed by someone trying to address gut problems, quietly making those problems worse. Breakfast cereals marketed specifically to adults, over 50 complete this picture. Many products formulated for digestive or heart health contain between 4 and 8 grams of isolated fiber per serving. Chicory root, oat fiber concentrate, soluble corn fiber, layered over a base of refined grain that has been processed and reconstituted into something that bears no structural resemblance to the original plant. The fiber molecules are present. The context those molecules need to function has been entirely engineered away. And every morning, millions of Americans pour milk over that bowl and feel, reasonably, like they're starting the day right. The next question, the one that changes how you read every label from here on, is what exactly happens inside the gut when these fibers arrive, and why certain ones cause so much more disruption than others. Most people who experience digestive discomfort after eating something labeled healthy assume the problem is with them, that their gut is sensitive, or that they ate too fast, or that stress is doing what stress tends to do. The possibility that the discomfort is a precise, predictable biological response to a specific ingredient, one a food scientist could have anticipated before the product ever reached the shelf, rarely enters the conversation. But that is, in many cases, exactly what is happening. And understanding the mechanism changes everything about how you interpret what your body is telling you. Inulin is the most widely used isolated fiber in the functional food industry, and it arrives in the gut with characteristics that matter enormously depending on the state of the microbiome receiving it. Inulin is a fructan, a chain of fructose molecules that human digestive enzymes cannot break down, which means it passes through the stomach largely intact and arrives in the colon, where bacteria ferment it. In a diverse, balanced microbiome, this fermentation produces short-chain fatty acids, particularly butyrate, which nourishes the cells lining the colon and helps regulate inflammation. That is the version of the story that appears in marketing materials. What those materials omit is the other version, the one that unfolds when inulin arrives in a colon whose microbial community is already compromised. Research published in the journal Gut has documented exactly this bifurcated response, the same prebiotic fiber producing profoundly different effects depending on the baseline composition of the individual's microbiome. Soluble corn fiber, listed variously as soluble dietary fiber or simply corn fiber, occupies a different but equally instructive position. It is manufactured through enzymatic hydrolysis of cornstarch, producing a compound that resists digestion and contributes to the fiber count on a nutrition label. The FDA includes it in its definition of dietary fiber based on evidence of modest physiological benefit. What that designation does not capture is how structurally removed soluble corn fiber is from anything found in a whole plant, nor how the aging gut responds to it at the doses commonly present in processed foods. Independent researchers have specifically called for more long-term studies in adults over 50, a population whose gut permeability and microbial diversity are already under pressure. Chicory root extract deserves particular attention because it has become so ubiquitous that many people consume it daily without realizing it. It appears under several names: inulin, chicory root fiber, fructooligosaccharides, or FOS, and turns up in protein bars, meal replacement shakes, low-sugar chocolates, and fiber supplements. At low doses, in people with robust gut health, it may offer modest prebiotic benefit, but the doses found across multiple commercial products, consumed in a single day, can overwhelm the fermentation capacity of a compromised microbiome. The result is not subtle. Bloating that feels disproportionate, a heaviness that lingers, bowel changes that seem random until you start reading ingredient lists with genuine attention. What connects all three of these ingredients, beyond their shared presence on labels, is that they ferment rapidly and in concentrated bursts, unlike fiber embedded in whole food matrices, which distributes fermentation gradually across a longer stretch of the colon. That difference in fermentation rate is not a minor technical detail. It determines which bacterial species get fed, how much gas is produced, how the intestinal lining responds, and whether the net effect moves your gut toward resilience or away from it. The food industry is aware this distinction exists. It has simply not found it commercially useful to explain. And what this disruption eventually connects to, beyond the gut itself, is more surprising than most people expect. There is a conversation happening right now at the frontier of neuroscience that most people over 50 have never been invited into. It doesn't appear in the standard advice about brain health, the crossword puzzles, the fish oil capsules, the recommendation to stay socially active. It lives in research labs and specialized journals, slowly accumulating evidence that the organ most responsible for your mood, your memory, and your ability to think clearly is not operating independently of your digestive system. It is in ways that continue to surprise even experienced researchers, taking its cues from what's happening 30 feet below. The gut-brain axis is not a metaphor. It is a physical electrochemical highway anchored by the vagus nerve, which runs directly from the brainstem to the abdomen, through which the gut and brain exchange a continuous stream of signals. The gut produces approximately 90% of the body's serotonin, the neurotransmitter most associated with mood stability and emotional regulation. It also produces significant amounts of dopamine precursors, GABA, and a range of neuroactive compounds whose concentrations are directly influenced by the composition of the gut microbiome. When that microbiome is diverse and balanced, the signals traveling upward through the vagus nerve tend to support cognitive clarity and emotional steadiness. When the microbiome is disrupted, when dysbiosis sets in, those signals change in ways that are measurable and in ways that accumulate over time. The National Institute on Aging has been tracking the relationship between gut health and cognitive decline with increasing urgency, and the findings emerging from that body of research are difficult to dismiss. Studies examining older adults with early-stage cognitive impairment consistently find measurable differences in gut microbiome composition compared to cognitively healthy peers of the same age, specifically lower levels of butyrate-producing bacteria and higher levels of pro-inflammatory strains. Whether gut dysbiosis causes cognitive decline, accelerates it, or simply correlates with it remains an active area of investigation. But the directionality of the relationship, the idea that what happens in the gut does not stay in the gut, is no longer seriously contested among researchers working in this space. What makes this relevant to the fiber conversation is specific and worth stating plainly. Butyrate, the short-chain fatty acid produced when beneficial gut bacteria ferment intact fiber, plays a documented role in maintaining the integrity of the blood-brain barrier, the selective membrane that protects the brain from inflammatory compounds circulating in the bloodstream. When butyrate-producing bacteria decline, as they do in states of dysbiosis, that barrier becomes more permeable. Inflammatory molecules that would otherwise be filtered out begin crossing into brain tissue. The result, over months and years, is a state of low-grade neuroinflammation that researchers increasingly associate with the cognitive symptoms many people over 50 attribute simply to aging. The brain fog, the word retrieval problems, the afternoons where focus feels like something you used to have. A diet chronically high in rapidly fermented isolated fibers, at the expense of the intact fiber that feeds butyrate-producing bacteria, may be quietly contributing to exactly this cascade. Mood follows a parallel track, and it leads somewhere that the standard conversation about mental health in older adults rarely goes. The connection between gut dysbiosis and depression has been documented in research published in the Journal of Neurology, Neurosurgery, and Psychiatry, with studies finding that alterations in gut microbiome composition precede, not merely accompany, depressive episodes in a significant subset of patients. This is not a claim that gut health explains everything about mood, or that rebuilding the microbiome resolves what medication and therapy are genuinely needed to address. The relationship is bidirectional, layered, and shaped by factors that extend well beyond diet. But it does mean that when someone over 50 reports feeling mentally slower, more anxious, or emotionally flat without a clear explanation, the gut deserves a place in that conversation, not as a last resort, but as a serious and under-examined starting point. The fog, the flatness, the sense that something is slightly off, in ways that are difficult to name, these are not always signs of inevitable decline. Sometimes they are signals. And signals, unlike decline, can be responded to. The question that follows is whether the microbiome, after years of disruption, still retains the capacity to do exactly that. The question arrives quietly, usually somewhere in the middle of a conversation like this one, once the weight of the information has had a moment to settle. If this has been happening for years, if the foods I trusted were doing something I didn't intend, and the effects have been accumulating in ways I couldn't see. Is it too late to change it? It's an honest question, and it deserves an honest answer. Not the optimistic version designed to keep you engaged, and not the fatalistic version that lets everyone off the hook. The actual answer, the one the science supports, is more nuanced than either, and in some important ways, more encouraging than you might expect. The microbiome is not static. That is perhaps the single most important thing to understand about it, and the fact that gets lost most often in conversations about gut health. Unlike neurons, which are largely fixed in number by early adulthood, or cartilage, which regenerates slowly if at all, the microbial community in your gut turns over with remarkable speed. Research published in Cell has shown that significant shifts in microbial composition can occur within 24 to 48 hours of a dietary change, not complete restoration, but measurable directional movement toward or away from diversity depending on what you eat. The gut is, in this sense, one of the most responsive systems in the human body. It is listening, constantly, to what you feed it. The problem is that it listens to the wrong inputs just as readily as the right ones. What the research is less encouraging about is the depth of recovery possible after prolonged dysbiosis, particularly in adults over 60. A study following adults who had undergone extended courses of antibiotics, one of the most severe forms of microbiome disruption, found that while diversity began recovering within weeks of dietary intervention, full restoration to pre-disruption levels was not achieved in all subjects even after 6 months. Some bacterial species, once lost from an aging gut, appear to be genuinely difficult to re-establish without deliberate, sustained effort. Harvard Medical School has noted in its published guidance that the aging gut has a reduced capacity for microbial recolonization compared to younger adults, not because recovery is impossible, but because it requires more consistency, more variety, and more time than the same intervention would demand in someone decades younger. The interventions with the strongest evidence behind them are, perhaps frustratingly, not exotic. They do not involve expensive supplements or elaborate protocols. The data consistently points toward 3 converging strategies: increasing the variety of whole plant foods consumed each week, not just the quantity, but the botanical diversity, since different plant species feed different microbial strains, reducing or eliminating the isolated fiber additives that have been displacing intact fiber in the diet, and incorporating traditionally fermented foods that introduce live microbial cultures in a food matrix the gut recognizes. A landmark study published in Cell in 2021, conducted by researchers at Stanford, found that a diet high in fermented foods increased microbiome diversity and decreased inflammatory markers more effectively than a high-fiber diet alone, with the important caveat that the fiber in that study came predominantly from whole food sources, not isolated additives. Timeline matters here because expectations shape behavior. Most people who make genuine, consistent dietary changes report noticeable shifts in digestive comfort within 2 to 4 weeks. Measurable improvements in microbiome diversity, as captured in stool microbiome testing, tend to appear within 6 to 8 weeks of sustained change. Cognitive and mood-related shifts, the downstream effects of a recovering gut-brain axis, tend to take longer, often 3 to 6 months, and are more variable between individuals. None of this happens automatically. It requires replacing, not just adding, which means that understanding exactly which foods are worth building a diet around is not a secondary question. It is the whole question, and the answer is more specific and more actionable than most gut health conversations ever get. There's a tendency, once someone learns that a category of food they trusted has been working against them, to overcorrect, to become suspicious of everything, to start looking for the next hidden threat rather than settling into a clearer, more grounded understanding of what actually works. That impulse is understandable, but it's worth resisting, because the science of what genuinely supports a healthy microbiome after 50 is not a story of restriction and suspicion. It is, in many ways, a story of abundance, of variety, of returning to a way of eating that is older than any nutrition label ever printed. The principle that anchors the strongest dietary research on gut health is called the food matrix effect, and it has already appeared in this conversation, but its practical implications deserve more space than they've been given. When fiber exists inside an intact plant cell, surrounded by water, bound to proteins and polyphenols, and resistant starches that slow its fermentation and distribute it across a wider stretch of the colon, something fundamentally different happens compared to isolated fiber arriving alone. The fermentation is slower, more distributed, and feeds a broader range of microbial species. The American Journal of Clinical Nutrition has published research demonstrating that whole food fiber sources consistently outperform their isolated equivalents in measures of microbial diversity, butyrate production, and intestinal barrier integrity, not because the fiber molecule itself is different, but because of everything surrounding it. The matrix is not packaging. The matrix is part of the medicine. Botanical diversity is the second principle, and it may be even more practically important than the distinction between intact and isolated fiber. Different plant species contain different types of fiber: cellulose, pectin, beta-glucan, arabinoxylen, resistant starch, and different microbial species in the gut specialize in fermenting each type. A diet built around 3 or 4 plant foods, however whole and unprocessed they may be, feeds only a narrow band of the microbial community. Research from the American Gut Project, one of the largest citizen science studies of the human microbiome ever conducted, found that people who consumed 30 or more different plant species per week had significantly greater microbiome diversity than those eating fewer than 10, regardless of whether their diet was otherwise considered healthy. 30 sounds like a large number until you start counting herbs, spices, nuts, seeds, legumes, and the variety within vegetable categories. It becomes achievable quickly, but only if variety is treated as a deliberate goal rather than a happy accident. Specific foods consistently emerge from the literature as particularly valuable for adults over 50, and they share a set of characteristics worth noting. Legumes, lentils, black beans, chickpeas provide a combination of soluble fiber, resistant starch, and plant protein that feeds a wide range of beneficial bacterial strains while slowing glucose absorption in ways that matter for blood sugar regulation. Whole oats, consumed as minimally processed rolled or steel-cut oats, rather than instant varieties, deliver beta-glucan fiber in an intact matrix that has been specifically linked to reductions in LDL cholesterol and improvements in microbiome composition by research cited in guidelines from the Academy of Nutrition and Dietetics. Cooked and cooled potatoes and rice produce resistant starch through a process called retrogradation, a fact that turns a simple meal prep habit into a meaningful prebiotic strategy. Fermented whole foods occupy a category of their own, and one that the Stanford research mentioned earlier elevated significantly. Kimchi, kefir, plain yogurt made from whole milk, sauerkraut, and miso are not fiber sources in the conventional sense, but they introduce live microbial diversity into the gut in a food matrix that protects those organisms through digestion far more effectively than most commercial probiotic supplements. Combined with a diet rich in botanically diverse, structurally intact plant foods, they create the conditions under which a recovering microbiome can actually rebuild, not just survive, but gradually recover something closer to the complexity it had before years of isolated fiber and processed food began narrowing it. That process is not immediate. It does not announce itself with dramatic improvements in the first week. It works the way most meaningful biological change works, slowly, cumulatively, and in a direction that only becomes fully visible in retrospect, when you realize that something that used to feel normal has quietly returned. The practical question, then, is not which superfoods to add to an otherwise unchanged diet, but how to identify and remove the imposters that have been quietly claiming that title for years. Reading a label with that knowledge is a fundamentally different experience than reading one without it. That skill is worth building carefully, and building next. Knowledge without application has a short shelf life. You can walk out of this video with a clear understanding of the difference between intact and isolated fiber, a genuine appreciation for why the food matrix matters, and a mental map of which ingredients to be cautious about, and still find yourself standing in a grocery aisle, label in hand, unsure whether what you're holding is actually what it claims to be. That gap between understanding and action is where most nutritional advice quietly dies. So this block is about closing it. Not with a rigid elimination plan, not with a list of forbidden foods, but with a reading framework that travels with you every time you shop. The first thing to look for is fiber quantity relative to ingredient source. When a product contains more than 4 grams of fiber per serving, and the ingredient list does not include a recognizable whole food, whole grain, legume, vegetable, nut, or seed in its first 3 ingredients, that fiber is almost certainly coming from an isolated additive. The math is simple. Whole foods contain fiber, but not in the concentrations that allow a heavily processed product to hit 8 or 10 grams per serving without help. High fiber numbers in low-integrity products are a signal, not a selling point. The American Diabetes Association has flagged this pattern specifically in its guidance on carbohydrate quality for people managing blood sugar, noting that fiber source matters as much as fiber quantity when evaluating a food's actual metabolic impact. The second layer of label reading involves learning the aliases. Isolated fiber additives rarely announce themselves plainly. They travel under names designed to sound natural, functional, or scientifically credible. Chicory root extract, chicory root fiber, inulin, fructooligosaccharides, FOS, soluble corn fiber, soluble dietary fiber, pea fiber, oat fiber concentrate, tapioca fiber, and Jerusalem artichoke extract among the most common. None of these names, encountered on a label, is automatically a reason to put the product back. But encountering 2 or more of them in the same product, or finding any of them listed before a recognizable whole food ingredient, is a reliable indicator that the fiber profile of that product is built primarily on isolated additives rather than intact plant structure. 30 minutes in, you already know this channel is different. Subscribe and keep it close. And if someone in your life needs to hear what you just heard, send it to them today. Now, let's go back to the label. It's still waiting, and its last secret is the one the industry designed specifically to never be found. The third element of a reliable reading practice is ingredient list length relative to product complexity. A whole food has 1 ingredient, or close to it. As the ingredient list grows, the distance between the product and its natural source typically grows with it. This is not an absolute rule. A well-made multigrain bread or a quality fermented food may have a longer list for legitimate reasons. But when a product's ingredient list runs past 15 items and fiber additives appear among them, the overall picture of nutritional integrity becomes considerably less clear. The NIH's Dietary Guidelines research has consistently found that dietary patterns built around foods with short, recognizable ingredient lists produce better long-term health outcomes than those built around nutritionally fortified processed foods, regardless of how the macronutrient numbers compare on paper. The fourth and final element is perhaps the most counterintuitive. Learn to be skeptical of fiber claims on the front of the package precisely because they are marketing, not nutrition. The front panel of any packaged food is legally considered advertising. The back panel, specifically the ingredient list, not the nutrition facts, is where the actual story lives. A product that leads with excellent source of fiber on the front and lists chicory root extract as its second ingredient on the back is telling you 2 very different things simultaneously. One is designed to earn your trust. The other is designed to be overlooked. The gap between them is where your shopping decisions get made and where they can, from this point forward, be made differently. There is a specific kind of clarity that arrives not when you learn something new, but when something you already sensed gets confirmed. A quiet recognition, not quite surprise, but something adjacent to it, that your instincts were pointing in the right direction even before you had the language to explain why. If you've ever eaten something technically healthy and felt worse afterward, or followed advice carefully and still didn't feel the way the advice promised you would, that clarity may be arriving right now. Because what this video has really been about is not fiber. It's about the distance that has quietly opened up between what the food industry calls health and what your body actually recognizes as nourishment. That distance didn't appear overnight. It was built incrementally, product by product, label by label, across decades of food innovation that optimized for shelf life, profit margin, and the appearance of nutritional virtue rather than the biological reality of how a 50, 60, or 70-year-old gut actually functions. The science was always there, or becoming there. Researchers at institutions like Harvard, Stanford, and the NIH were documenting the food matrix effect, the limits of isolated fiber, and the fragility of the aging microbiome, while those same isolated fibers were being scaled into mass production and marketed as solutions to the very problems they were quietly compounding. This is not a conspiracy. It is something more ordinary and, in some ways, more troubling than that. A system optimized for metrics that don't fully capture human health, producing outcomes that accumulate slowly enough that the connection stays invisible until someone points directly at it. What changes now is not your entire diet. Overhaul is rarely sustainable, and sustainability is the only metric that matters over the long arc of time this conversation is really about. What changes is your operating framework, the lens through which you read a label, evaluate a product, or decide what earns a regular place in your kitchen. Whole food fiber over isolated fiber, botanical diversity over nutritional uniformity, ingredient lists that read like a market, not a chemistry lab, fermented foods alongside plant variety. These are not restrictions. They are a return to a way of eating that the human gut spent hundreds of thousands of years learning to expect, and that it is still, even now, entirely capable of responding to with something that feels, unmistakably, like relief. The gut is not a passive system. It does not simply receive what you give it and process without response. It communicates through comfort and discomfort, through energy and fog, through the kind of steady, unremarkable physical ease that most people don't notice until it's been absent long enough to recognize as a loss. What the research collected in this video points toward, from the Gut Journal to the National Institute on Aging to the Stanford Fermented Foods trial, is a consistent and increasingly hard-to-ignore conclusion. The microbiome responds to care. Not immediately, not dramatically, but reliably, in ways that extend well beyond digestion into cognition, mood, inflammation, and the broader arc of how the years ahead feel from the inside. You have been making choices about your gut health every day for years. The difference is that most of those choices were made without the full picture, with labels that told partial truths, with marketing that borrowed the vocabulary of science without its rigor. That changes when the mechanism is finally clear. A real choice made with accurate information by someone who has decided that the decades ahead are worth eating for. If this conversation was worth your time, subscribe to this channel and share it with 5 people in your life who are eating carefully, but still searching for answers they haven't found yet. And leave a comment below telling us what you want to examine next. The list of topics that deserve this level of honesty is long. We're just getting started.